Okay, so this problem here, we're asked to find the area that's bounded by the equations y equals x minus 1, y equals the square root of 3 minus x, and y equals 0. So I take a moment here and graph my two equations along with the x-axis, the line y equals 0. Because otherwise, if I don't have that, then I don't really have a bottom boundary. Okay, this thing would actually, what would we do? Particularly since the graph of square root doesn't continue below the x-axis. So, but we do have the bottom boundary here. And so we're looking at this region right here, this triangle with a little curve on its side. A curved triangle, if you will. Weird looking slice of pizza, maybe. Okay, so we want to find this area. Now, what I want you to notice is we could do this with respect to x. So if we did it with respect to x, we would actually decompose this into two pieces. Right? You'd have this piece from the red triangle going from 1 to 2, where this red function would be your top function. It'd just be the area between that and the x-axis. And likewise, then you can do plus the integral from 2 to 3 along the x, where the blue curve is the top function, the square root of 3 minus x function. Right? And you could do that. However, we're going to do it in one fell swoop because I can look at this going vertically along the y-axis from 0 to 1 of the gap between the two, the red and the blue. Do it all in one, just straightforward integral. Okay. So let's paste in our graph and let's investigate our problem here. So first things first, we're going to be doing this way. So I notice my y's are going from 0 to 1. Right, 0 to 1 along the y-axis. And I also notice that the blue function is the right function and the red function is the left function. Now, again, before I can integrate with respect to y, I do need to take my equations, and I need to solve those for x. Okay, so let's do that real quickly. Y equals x minus 1. We would just bring the 1 over and get x equals y plus 1. For the second equation, we would have to first start by squaring both sides. And then we need to solve for x. So I'm going to bring the x over and flip-flop it with the y. So getting my second equation there, x equals 3 minus y squared. My other one there, x equals y plus 1. Okay, so again, the x equals y plus 1 is the red graph, which is the left one. And x equals 3 minus y squared is the blue graph here, which is the right function. And we can see again on the y, we'd be going between 0 and 1. So we set up our integral and work it out. So that'll be the integral from 0 to 1 of the right function, 3 minus y squared, minus the left function, y plus 1, dy. Okay, and so then we work out that integral. So I'm going to ask you to maybe pause the video and take a moment and do that, and then just to kind of see where you're at. Okay, welcome back. As we simplify here, this would be negative y squared, combining my like terms, minus y plus 2 dy. So if we continued here, we'd have negative 1/3 y cubed minus 1/2 y squared plus 2y evaluated between 0 and 1. Okay. And then you can just go ahead and evaluate that. Plug in 1. You'll have negative 1/3 minus 1/2. Negative 1/3 minus 1/2 will be a negative 5/6. Plus 2 will give us 7/6. And of course, when you plug in 0, everything is 0. And so we get our answer of 7/6. So this area is 7/6 square units.